All right, babies, let's do this. Example 3, very similar to example 1. I have a table here that is a probability distribution for a discrete random variable. And my discrete random variable is temperature in Fahrenheit. So we're looking at ostrich eggs. I know, everybody's favorite topic. You're welcome. So a large quantity of ostrich eggs are placed in incubators at these different temperatures, and then the probabilities they'll hatch at those given temperatures are listed underneath. So find the expected value. Okay. Easy peasy, lemon squeezy. Yes, you can do this by hand, or you can write out the formula like I'm doing and then use Staplet. It does not matter which way you do it. Variance and standard deviation. So the variance, remember, is the standard deviation squared. Okay, so I'm writing my monster formulas again. Yay. And then the standard deviation. So I'm going to go to oh man. I'm going to go back to Staplet, discrete random variables, and what is this called? Ostrich eggs. How could I forget that? I just made fun of that. It's actually ostrich egg temperature, so we're just going to shorten this here. Okay, and I've got 5 temperatures, so I'm going to put all of those in there. So we've got 99, 100, 101, 102, and 103. Hopefully you figured out how to type things into Staplet by now. I know it's really exciting, so you're welcome. I guess I could sing to y'all while I do this. No, I'm kidding. I wouldn't do that to you. Poor babies. Okay. So there's my mean and standard deviation. You will have to calculate the variance by squaring the standard deviation, but that shouldn't be a big deal. So I'm going to go back to my notes here. And my mean is 100.85, and this is in degrees Fahrenheit. And then my standard deviation is 1.19, I think that's what it was. And then my variance, of course, when I square that, 1.4275, something like that. Okay, so we've done this several times now. I'm sure you've gotten the hang of it. Now we're going to look at the carnival game. This is where things get interesting. Okay, so take a moment to pause this and read the situation so that you'll know what's going on. And then what I'm going to do is I'm going to show you how to create the probability distribution, because you'll notice that you're finding the expected profit in the long run, and then you're asked, is it wise to play the game? So we are going to let X represent the amount of profit, not the amount I'm winning, but the amount of profit. So it is important that you understand the difference, because if you'll notice, it does cost money to play this game. Costs you $2 every time, and you get 3 rings. So when I create my probability distribution here, I've got X and I've got the probability of X. Okay, let's think in terms of profit. Well, one of several things is going to happen. I'm going to plop down my $2 and they're going to give me 3 rings. So if I get each of those rings, all 3 of the rings around a bottle, they're going to hand me 20 bucks. I will have profited $18 because I had to pay $2 to play. Okay, another outcome that could happen, I plop down my $2, they give me 3 rings, I get 2 of them, I miss 1 of them, they hand me 10 bucks, I have profited $8. Next scenario. I plop down my $2. They give me 3 rings. I miss 2 of them. I get 1 of them. They hand me $5. I have profited $3. And don't forget the other scenario. I plop down my money and I miss all 3 rings, which means I am out $2. Poop. Okay? Yes, you can have a negative up there. That's usually the easy part. The difficult part comes in when we're trying to find the probabilities. So let's think about what happens. I'm going to change the color here so we can distinguish this. Okay, so at $18, okay, so when I have a profit of $18, that means that since the probability of getting the ring around the bottle is 20% or 0.2, that means ring 1, 0.2, ring 2, 0.2, ring 3, 0.2. When I multiply those together, I get 0.008. Okay, now let's look at the $8 scenario. This means that they give me 3 rings and I am going to either get the first 2 of them or the last 2 of them, or I'm going to get the first and the last one. So let's think about this. If I win with 2 rings, that means the probability I win the first one and then the second one, and then I lose on the third ring, or the probability I win the first one, lose the second one, win the last one, or the probability that I lose the first one and win the last 2. You have to take all of the orders into consideration. So what's going to happen here is I'm going to multiply this, and it's going to be the same thing for each of these. So when I multiply 0.2 times 0.2 times 0.8, I get 0.032. So 0.032 plus 0.032 plus 0.032, or 0.032 times 3. That gives me 0.096. Remember, for your probabilities, you have to take into account all the ways I can profit that $8. All right, going to do something similar here for $3. They give me 3 rings, and now I'm going to win on one of them and lose on the other 2. So that can happen this way. I can win on the first one and then lose, or I can lose, win, lose, or, I was supposed to use the word or there, or I can lose, win. This value, 0.2 times 0.8 times 0.8, is 0.128. So that is going to look just like that, or 0.128 times 3. So that gives me 0.384. And then what you can do to find your $2, your negative $2, you can either add these 3 together and subtract from 1 to get it, or you can just take 0.8 times 0.8 times 0.8, which means you lose, and then that's going to be that value right there. Double check yourself and make sure that all those values add to 1. All right, we're almost done with the question. All right, so find the expected profit in the long run. So my expected profit, of course, is going to be my weighted average. So I'm just going to write this down here. And then, of course, I am going to go to Staplet and find the answer. I'm not going to do that in this video because we've done that enough. I get $1.04. That means that if I keep playing this game many times, I will average a profit of 1.04. So if you're willing to play it long enough, and if you're willing to lose a lot, then you will eventually come out on top with $1.04 extra in your pocket. So depending on your patience and your optimism, how you answer this question could change. Is it wise to play the game? It depends on how willing you are to lose, and how often you're willing to lose, and how long you're willing to play the game. In my personal opinion, I'm not really sure $1.04 is worth having to play it as much as you're going to have to play it in order to average that kind of profit. But that's just me. Okay, I'm going to do another video with more examples. I know